Now the classic fatal error, and it comes straight out of the last lesson. Local has automatic storage duration. It exists from its declaration until its block exits, and its block is the function. So the instant broken returns, local is gone, but we returned its address. Main now holds a pointer to a variable that no longer exists. That is called a dangling pointer, and it is the single most common serious bug in C. Read the function again, because this is the thing worth noticing. Nothing about it looks wrong. It is 4 lines. Every one of them is legal C. The value 42 is real, the address is real, the pointer type matches. The mistake is invisible in the code and lives entirely in the lifetime rules, which is exactly why it takes people so long to learn. Here is what is really going on. While broken is running, local sits in broken's stack frame, holding 42, and P points at it. When broken returns, that frame is popped. The memory is not erased, nobody wipes the stack. That would cost time for no benefit. The bytes are simply no longer yours. So dereferencing P often prints 42, and the program appears to work perfectly. Then you add a printf call between the 2 lines, or compile with optimization on, or run it on a different machine. And the next function call reuses that stack space, and your 42 becomes something else entirely. This is the worst possible failure mode, a bug that passes your tests. Getting the right answer from a dangling pointer is not evidence of anything except that nothing has overwritten the slot yet. The good news is that -w all catches this exact case. Warning function returns address of local variable, which is one more entry on the list of reasons to compile with warnings on and treat them as errors. There are 3 honest ways out. Return the value rather than the address. For an int, just return int. Have the caller supply the storage and pass you a pointer to fill in, which is how a great deal of the standard library works. Or allocate on the heap with malloc, which has allocated duration and outlives the function, at the price of somebody having to free it. What -w all count catch is the general version of this bug, storing a pointer to something that later dies, in a struct, or in a global, or in an array, where the def and the use are in different files. That is the real enemy, and chapters 12 and 14 go after it directly.